Good day everybody and welcome back to the channel. So, I've got some pretty cool news for you guys. Two things are happening. One, today I am ordering those 2 big transformers. I did the math on it with the, I can't remember what it was, 42 volts or something. I've got it written down. I'll have 54 volt rails. Loaded down, it'd be probably closer to about 50 volts. And then with the additional sag of the amp going on top of that, it'll probably be around, I don't know, 44, 45, 46 volts, something like that, which is still a few volts headroom off of 250, even maybe 300 watts into 8 ohms. I did some further research, or should I say math, into power dissipation. If my rails are lower, at a 4 ohm load, even only having 250 watt devices on the NPN and PNP side, so 4 devices per channel, this will be able to do over 250 watts a channel. Let me explain. Take 2SA1492, 2SC3856 for example. They've got a safe operating area that's as high as these devices, which are 30 watts, 20 watts larger than the 130 watt Sanken devices I'm talking about. Now, they get run on a heatsink that doesn't exceed 60, 65-ish at the most, and again, 4 devices per channel, and that was doing 250 watts into 4 ohms. It was doing 165 watts into 8 ohms, but that's because the PR rails were like 63 volts or something, so the transistors were trying to dissipate too much heat. Anyway, so I am ordering those 2 large transformers today. I've had to think about this. For the life of me, I've spent a long time, as you can see, trying to rearrange everything in here, and I'll just grab the rest of the parts that have to go in here. So I mean, I could drop, let me just put the light on my phone. All right, I could drop the temperature controllers in the back sort of thing down there. All right, the input protection we don't know that we need yet. Depends on the inrush current. I might just end up slapping the 0.1 mic across the primary winding and not need that. So these boards, I'll leave them out because they're a maybe. All right, the only other things that have to go in, there's actually room for the driver boards. It's this that's the problem. All right, I've tried moving this around in every which way, and the only way I can get it to all fit in here is if I was to put the caps in odd places like here. And then I'd have to run, really long wires. There'd be wire going from there to the fuses, from the fuses to the rectifiers, then all the way over to here to the caps, then all the way back over to... I don't want that much length in wire. Yes, I can use ridiculously thick wire, I guess, but... it's quite cramped. And I also don't really want to add more airflow to it. So the thing is, this case has got these cutouts in the bottom on each side. And no, I wasn't going to put the heat sinks flat down on them. I'm going to put risers, right? So the heat sink sits just a bit above that. And then the fans go on the front of the heat sink and pour air in. So it's going to suck air out the holes, up into the front, into the heat sinks, and then gets blown out the sides of the heat sinks, right? And then that air is going to come up into the top, and it's going to come out the top cover, right? So that's fine. With the forced fan cooling, that'll be fine. If I have to add some extra miniature fans to these vents or the top vents to get some more air through the case, I'll do that too. That's fine. But here's the thing. Let me see if I can set my phone down somehow. Hold on. Let me just put a toroidal transformer sort of on the edge of my phone. There we go. Right. Now I can really give you guys a good look. And the 2 transformers I'm ordering, they're going to be sort of probably about that wide. Maybe a bit wider. Probably about that. Now in between that and that, but they're circular, not long, right? Anyway, I might use these. I might use the ones I'm ordering. I'm ordering them anyway because I've got a huge amp to build after this one. So, anyway, now here's the other thing I've been thinking about. Like I said, I'm not sure about what I was going to do with capacitors, but even if I was to try and do this, it would be 8 of these. That's only 4, right? Look how much space that takes. I've got the other 4 here. What I'm saying is there's no way I'd fit all that in the one case. The only reason the driver board's fitting now, incidentally, is because I can put a metal plate that goes from here to here and install them like this, and the plate will provide shielding from the transformer, so that will work nicely. So what I've decided to do, it's taken me literally like a week to get the money together, and it's left. I'm going to be broke for a few days, maybe the better part of a week, but it's worth it to me. So I'm getting these transformers today, and then maybe in another 2 weeks I'll order another one of these cases. So what I'm going to do is I'm going to lay it out a bit different, and this will be better too, because then what I can do is I can put the transformer in the middle at the back. You know, I can say have, let's see, you know, like my input protection circuitry thing can go there. The fuse block for the output of the transformer could sort of go there, you know. The rectifier could get mounted there where it's got airflow underneath it, you know. The cap bank could go like that, you know, or like that if you want to be technical. It depends how I mount it. And then, you know, I'd be able to put this, lift it up a little bit like this with the fans on the front of it, which would be drawing all the air in the front and then spitting out the sides. Or I could turn it around the other way and do that so it's drawing air in away from this stuff too, which is probably the better way of doing it. But there's a few options in terms of fitting everything in here like this. Do you know what I mean? It's just, it seems more logical. The other thing I was thinking about last night too was this. Basically leave the input board here, but sort of turn it around. Put the transformer sort of over the air vents. So it's got air coming from underneath it. These are oversized for the job. They don't get hot anyway. I used to pump over 500 watts out the amp they were in originally, and the transformers, I think they didn't even get warm. But so again, it would sort of be rectifier over the cooling like that. Actually, that works perfectly. Screw holes actually line up with the slots. Yeah, I'll do that. So put that there, maybe there, and put the fuse on the other side, you know, just to save space. And then sort of put the cap bank yeah, that's alright, that's not restricting airflow. Right, I could do that. I'd probably actually lay it out like that. Wires to that, to that, to that, and then straight to the amp. You know, and then I'd put the power module here where these slits are in front, so the fans could suck the air right out of there into here, blow it out the sides, and, you know, heat rises. So that would sit about there. And I would be able to put it flat on the bottom. I would put it on risers anyway. Although, I don't know. I mean, if it's on the bottom, the bottom of the case becomes a part of the heatsink too. But I think that would help build up more heat than anything. So it's probably better if I do just rise it a little bit. Yeah, and then it also allows it to pull a bit of air in from over this side too, with the fans. And you see, if I do that, I then have, I can move this halfway over those slots because it's going to be lifted up, so it'll be like that. And then I've got all this beautiful space in the center for my driver board. Nothing needs to be cramped anymore, Right, and then there's my fan controller. Fan controller would just sit like that. Actually, to be honest, I'd put the fan controller over here just in case some sort of noise off of that ends up in the front end stage. But I'm thinking that's what I'm going to do. And then there's still other bits and pieces. I mean, like I've got to get the RCA jacks for the inputs on the back, right? I've got to get, well, now it's only 1 amp per box, a couple of outputs on the back. I might not use these because I don't even understand how you're supposed to use them unless you put some sort of insulated washers and unscrew these and drill holes through the case or whatever. I'll work it out. But that's all stuff that gets fitted into the case. Well, 1 power switch because 1 amp, 2 volume knobs because again 1 amp, inline fuse holder which screws into the case. So all this stuff gets mounted on the case is what I'm getting at. Same with the 2 pots, they're going to get mounted on the case. You got a little bit of cabling to wire it all up to the RCAs. Got a little bit more cabling to wire the rest of the stuff up, and a few other gauges, I think that's what I'm going to do. And that is already insanely heavy. I mean, that's like 15, 20 kilos. And I'm pretty freaking strong. Like, you'd be quite surprised. Not to brag, I know I'm not the biggest person. The thing is, I've worked my whole life doing hard work. I started working on construction sites at the age of 16. I was already doing stuff before that. I do building work, I do mechanical work, I build stuff, I ride a bike. I'm pretty fit and strong. And I can tell you now, that's 15, 20 kilos. When I had both the amp modules and transformers in there, I went to pick it up last night and it was like, oh, wow. That was like trying to pick up 2 20-kilo bags of cement at the same time, which I'm used to. So that's why I'm saying, I'm not trying to brag about how strong I am. I'm trying to say, like, I've got a good feeling for weight because I'm used to doing these sorts of things, like carrying 1 or 2 bags of cement. So I know what it weighs. If it's a 20-kilo bag, it's 40 kilos. I know what that feels like. So, yeah, I think that's what I'm going to do. 1 case. It's, 15, 20 kilos per case of stuff. And this way there is space around things, It's not like the transformer's right next to the board coupling into it. I'd probably move that actually over there a little bit more. Like that, There's going to be awesome airflow. Even as heat sort of does build up in the case, there's that much space for it to disperse and find its way out the vents. It just works, The case is aluminium too. So the entire case being aluminium, is going to act as a heat sink for the air temperature, if that makes sense. So all the air in the case gets the case warm and it dissipates it instead of building it up, is what I'm trying to say. So I think this is what I'm going to do. So I'm going to go up to the bank now. I'm going to order these 2 transformers, and then this is the second part of this video that I wanted to talk about. So I'm going to set up transformer, cat bank, rectifier, driver board and amp module on the bench now. We're going to load test it and see what the thermals are like with fans, without fans, all that sort of stuff. I've got a funny, I set the gain on this, it's 26. It's got a gain of 26. Now, I have a funny feeling, because I built an amp similar to this before that had tip 41, tip 42 devices. And 2SC5200s and 2SA1493s, and drivers, pre-drivers only had an HFE of 150, higher cob. I did a much better job on this amp. And instead of having these 150 watt devices too, but a higher SOI, and 2 fans on the heatsink instead of 1. I got a funny feeling that I'm going to get 340, 350 watts per channel out of it into 4 ohms. And if that's the case, if the heatsink is say 55, 65 degrees, I'll leave it. That's all right. That'll be getting into the SOA area on these transistors. It'll be into it, but they'll take it. If it wants to do 350 watts a channel easily, but they get too hot, well, I'm going to have to change them. I've got 200 watt output devices. I've got come on, MJL21193s and MJL21194s, and I've got MJW1302s and MJWs3281s. So, we'll see what happens. The reason I'm thinking about going for that is because whether I have this transformer or the ones I'm buying, they're bloody massive. The cat bank's massive. Everything's just so overdone. I don't think this is going to be a 250 watt per channel amp. And a huge box like this, just for 250 watt channels, it's alright, but it's a bit overkill. If it was, say, 650, 700 watts for the whole box, 750 even, I'd be happy with that per box. So that's what we're going to do. So without further ado, I'm going to take what you see here back over to the bench. We're going to wire it up. I've got all the power supplies set up on the bench first, still, so I can power this up first, just to guarantee that it is still working, the bias isn't run away, this and that. And then as long as that's all good, we'll hook it up to its power supply, stick some signals into it, hook it up to the load bank, and load it up. I don't think that gain problem that I had, I wouldn't have put all this effort into this continuing to build it if I thought that was going to be an issue. I had dodgy transistors, current limited power supplies, thin little wires, no bypassing, breadboards. There was a myriad of reasons that was happening. Yeah, I'm pretty sure this is just going to go with no problems. Yeah, I've already sorted out stuff like cross distortion and stuff because I'd already started building this amp a couple of years ago. So there's a lot of stuff that is already correct on it, so it's pretty well ready to go. Like I said, what I intend on doing now is sort of just research on how to make things even better than what they are in terms of starting a high-end audio business, but for what I've got here, I'm completely comfortable with it. I think it's going to be a wonderful performer. Obviously we'll see. Sorry, I'm going to bring the camera over here. It's just a bit hard carrying toroidal transformers at the same time. Alright, so like I said, I've ordered those transformers. I'll just use this cap bank for both tests. That's going to drop voltage, so that's going to be a bit under 63, and then when I get the proper transformer, it's going to be way under it, so not way, but enough. So I'll just use this cap bank, and I don't have to muck around with another one. I mean, it depends on how this thing goes. If it ends up being fine in terms of dissipation at, 250 watts at 63 volt-ish rails, I might leave it. But at the same time, if I can turn the rails down a bit and actually get like 350 watt out of it, I'm definitely going to use this. If it ends up being 63, I will use those big cylindrical 100 volt caps and those new MKTs that I got that are slightly better than them. I'll just build a bank of those to go with. I'll just mount them across the top of them. I mean, they're really big caps. I've already shown you guys the cap that I'm talking about. So what I'd be doing is I'd be using 4 of these for each transformer. So grand total of 8. Do I have any more? No, 8, yeah, that's all I've got. I wouldn't mind having 30,000 mic on each rail. I've got 28,000 mic roughly here on each rail. That's what I wanted. Yeah. Anyway, I'm going to get this all wired up, and then what we're going to do is, well, first we'll just run a signal through it and see how much unloaded swing there is, and what it's doing, all that sort of thing. Then I will set this up for 2 4-ohm loads, and don't forget I've got BNCs down here, so then we can run that into the scope and have a look at what's going on. We can see what power we're getting out of it, how the heatsink temperature goes. The bias at the moment, it seems perfect. I want to see how it is when the heatsink warms up, how quickly the bias string tracks with that. It seems exactly like it was the first time I built this setup. These are the exact same diodes. They're only running a couple more milliamps through the string. If anything, that should make them, track faster, I think. Maybe I'm wrong. They're probably more sensitive at a lower current. I don't know. I'll have to look into that. But, I mean, the other day I powered it up, and within a minute or two, the bias came up to about 18 millivolts and just stayed there, and the heatsink got warm and it stayed there. And the heatsink got warm nice and quick, so the diodes tracked really quick and it just stayed there. So I can't imagine, if it gets even hotter, they're only going to track more and bring the bias down even harder. So, I think that's fine. And like I said, because 2 of the diodes have been replaced with Schottkys now, the bias is going to be low, so those pots that are bottomed out will end up somewhere in the middle. So all this should work now. I'm still going to power it up, wire this up to this and power it up off of the power supplies. I've literally still got them sitting here. I've left it here the whole week for this reason, just to make sure, and then if it powers up, bias tracks, I'll run a signal through it, touched input. I just want to make sure it's stable and it doesn't break into oscillation or something like that, and if that's fine, then we'll wire it up to the big power supply and just start loading it and testing it. Obviously, we've got a scope to look at what it's doing whilst we're loading it. So if, I start turning it up and the waveform starts flattening out or collapsing or something terrible, indicating that it's literally microseconds away from blowing up, I'll be able to kill the power. So, yeah, I'm pretty good with these things. I'm not the most experienced person on the earth. I haven't built that many amps, but I've worked on a crap ton, and yeah, I'll be alright, don't worry. Worst case scenario is things do get blown, just got to replace them. I've got a funny feeling that this is going to be an overperformer, and that I'm going to end up wanting to take the 150 watt devices off the heatsinks and replace them with 200 watt devices. And I ordered transistors because I was going to build another amp after this that was more powerful, but it looks like this is going to be that one. These are all 200 watt devices. Obviously, for this, I'm going to use these. They're going to be able to dissipate heat into the heatsink faster and better because of the larger surface area. So I'm going to use them. I've heard rumors that the SPTech transistors have got a slightly smaller die than the onsemi brand, but they're legit transistors and perform well. So I'll definitely be going with the MJL 21194s and 21193s. Pretty sure they're 200 watt devices. I have to double check. I'm pretty sure they are. I know they are. I think they both are, yeah. They're 200 watt devices. So, I'll do that. Yeah. I can't see the transformers I'm buying or these ones giving more than about 350 watts, both channels loaded. If it does, I might have to get 250 watt devices. I'm pretty confident the driver stage is fine for it because, see, the first amp that I had built, the drivers were tip 41, 42, and their gain's only like 15 to 75, and that's unloaded, right? My outputs are 2SC 5200s and 2SA 1943s. We've got transistors that have got way better gain at higher current here on the outputs. Same thing with the drivers. I think the transistors I was using before, their gain would have buggered off after an amp or two. These have still got gain at 4 or 5 amps. My pre-drivers are about double the size in power dissipation of what I was using before, and everything's got more gain and more drive. So, that coupled with the power supply, that's what, and a gain of 26. That's why I say I don't think I'm going to have any problems getting ridiculous power out of this thing. So I wouldn't be surprised if the transistors end up getting made bigger. I've used this heatsink before. I don't understand how it works. I wish someone could explain this. It's a really odd heatsink. The way it came out of the amp, right? This is what got screwed down to the bottom. You can actually see some holes in the bottom. I drilled them out to make them bigger and added one for an old project where I had this mounted in a different way. But as you can see, there's nothing on the top. This was mounted with all the transistors on the top like this. And it's got this funny little thing where the section on the transistors goes, sort of comes out and then goes in and down like that. I don't know if that somehow like makes the heat wick down, because heat rises. I don't understand. But the thing is, I built one of these that was supposed to be 250 watts a channel and dumped 1,000 watts out of it. And yeah, the heatsink got bloody hot and I had to put fans on it. And once I put fans on it, it cooled down and it was still dumping 1,000 watts. I couldn't understand it. And that was only with 8 2SC 5200s and 2SA 1943s. Like, I was massively overloading those transistors, but I was running them really cool. And so that's why I say, like, I wouldn't be surprised if this thing tries to spit out a ridiculous amount of power. And that heatsink is really efficient, especially, I think it's something to do with the design of it, this like little section here, and then how it goes in and down, and that's a bit like thicker and it's angled. I think when you add fans to it and this, it sort of reverses, makes it wicks the heat into the whole heatsink, pulls it down instead of all rising. It's really interesting the way that works. And there is still a good thermal coupling because the devices are so close to the diodes, so it still does work. But you'd think that like these top couple of fins would be red hot and the bottom would be cool. It's not that way. I've used it and it didn't work like that. So yeah, if anyone's expert in thermal design, explain it to me. But I think it's got something to do with that, the way it's cut like that and the fans pulling the air through it. But yeah. Anyway, I'm going to get this set up. Well, not right now because I've got a few things to do, but today that's what I'm doing. So we'll get this set up and we'll see what we've got. It's going to be fun. I was just having a look at the data sheet for the 0281s and 0302s, NJWs. 40 volts at 4 amps, 100 milliseconds, which if I'm not wrong is 10 hertz, which is, as much power as the amp's going to be pulling at 10 hertz with the music I play and the subs. But anyway, what I'm getting at is that works out to around about 160 watts. Now these are only 150 watt devices, but what I'm saying is you could almost squeeze the entire 150 watt, or you could squeeze the entire 150 watt dissipation out of it. Obviously you'd have to keep it theoretically cool at like 25 degrees or whatever it is. But when I was looking, like I said, I was just looking at the SLA curve for voltage versus amperage. And like I said, it's up there quite well. Now, even if it's running at like 55, 60 degrees, that's only around about halved, which that's still going to leave me quite a bit of dissipation. Let me just do the math and I'll tell you what it is exactly. Yeah, so the PNP side would be able to dissipate for each channel 150 watts and the NPN side 150 watts. So I got a funny feeling I'm going to end up getting 300 watts a channel out of this. It's completely doable as long as I can keep the transistors cool enough, basically speaking. Like, this is the thing a lot of people don't know. There's no hard and fast rule with headroom. It's not like, have to use a 150 watt transistor for a 100 watt output stage, or you have to use a 125 watt transistor for a 100 watt output stage, or whatever. It depends on the temperature and the voltage, because the voltage versus collector current and the temperature versus power dissipation is where your safe operating curves are. And the thing is, if you can keep the voltage low enough that the collector current is high enough, the transistor can literally dissipate its full rated power. Then you just have to keep it cool. So it becomes, you could theoretically need an extra 10 watts, an extra 20 watts, an extra 30 watts, 40 watts, 50 watts. It just depends on really your heat sinking and cooling is what I'm trying to get at. And the voltage. So that's why I ordered the transformers, by the way. So I'm going to have unloaded 54 volt rails. With it running, like with bias and everything, it'd probably be about 50. Once music starts playing and it sags down, that'll be pretty close to the maximum voltage. It'll be probably, if I turn it up at 8 ohms and try and drive 250, 300 watts, I don't know that I'll get 300 watts at 8 ohms, maybe 200, 250. I got to work out power dissipation, which way is worse. I always get confused on that. Anyway, I've lost what I was saying. Anyway, I've said enough. I think that made sense what I was trying to say. So I might be alright with the devices I've got on the heatsink. Basically, what I'm going to do is I'm going to aim for 300 watts at 4 ohms. If the heatsink is comfortable temperature wise at that level, we'll see what the power transformer does. If the power transformer literally never even gets warm, I'm going to put 200 watt devices on the heatsink, because there's no point in my mind having all of this, all of this, all of this, all of this, and all of this, and then output devices that are too small. It's going to piss me off so much, because I've already had to take everything back off to change the drivers because I put fakes on there. But, it's all right. It's a learning curve. I won't be making these mistakes again. Next time I'll tell you, I'll be doing all my planning before I start building, and I'll be testing transistors too a lot more thoroughly instead of just trusting that they're real next time. I mean, I've sort of got that problem solved now, so I don't think I'm going to have any more issues with that, but still. So I'm going to get this wired up now. Let's see what it does. I'll bring a couple of fans over here, one for the PNP side, one for the NPN side. I'll hook them up to some steady voltage, like 9, 10, 11, 12 volts, to simulate. I run them at 12 volts. That'll simulate the two fans running at full speed, and then we'll literally just turn it up until the heatsink gets, 50, 55, 60-ish degrees, where I'd start feeling uncomfortable with the amount of power and voltage that is getting dissipated on the devices, and we'll see what that level is. And we'll go from there. Like I said, then it's going to be a matter of what the transformer's doing, and also how hot the heatsink gets, which will dictate whether I put bigger output devices or not. But yeah, let me just say this. When I built this before, I overloaded it and pulled 1,000 watt out of it, which was fucking hilarious. Sorry, excuse my language. For two SA 1943s and two SA 5200s, 4 on each side, I pulled 500 watts out at 2 ohms of each channel, and it took it. I was drunk and I did that for hours. I did have to get fans to cool the heatsink down. I don't know how it didn't blow, but it didn't blow. And these devices are stronger, so yeah, it really remains to be seen what happens. It's going to be interesting. Anyway, I'm going to get this hooked up now. We'll see what happens. I am so G'd. I'm going to use the actual wire that I'm going to use to wire it up in the box to wire it up. I'm just going to cut the pieces a bit longer and then cut them shorter in the box, because we got to deliver current, and I don't want inductance and stuff in the circuit now, because I'm basically hooking it up as it's going to be in the box. I've completed the wiring looms for the output stages, so the drivers have got their collector power. Everything's separate, I figured some people put capacitors on the collectors of the drivers. Some even do for the outputs. I figured if I use really stout wires that are short and thick to go straight back to this chunky ass bank for the outputs, that's going to be fine. And if I run the collectors off completely separate wires, so the current's not flowing down the same wire as the outputs pulses, you get what I'm saying? So that's why I've done that. And then everything on here is all separate and decoupled beautifully, as you know. So yeah, this is going to be good. The reason I've done this, like I said, is I want really good quality, but I also want really good stereo separation, channel separation. So yeah, I'm going to get this hooked up now. We'll see what we get. I truly can't wait. So for those wondering, this is the gauge of the wire that I'm using. This is about 2.75. I'm not sure what that is, but it's also pretty thick. This is rated for like 7.5 amps. This is just for the driver transistors. This is like, I don't know, 25 amps, 30 amps. I mean, it's such a short run. You could probably get like 50 amps through it. Like, this is great. The power wires and ground wires for the board, same stuff. Feedback wire, this isn't that little J-car wire. This is the stuff I was showing the other day it's got the thin insulation and pretty thick gauge in it. That's the feedback wire. That's all I need. I've got power wires for the output stage, power and ground for the driver board, feedback to go from the output to the driver board, and now I just need to make up my wires that go to the bias string and the bases. I haven't worked out what I'm going to use for that yet, so I'm going to get to that now. I know exactly what I'm going to use. Anyone remember the good old 4-core, 6-core, 8-core, not Cat Ethernet cable? It was used for telephones, but mainly for alarm systems, for like PIR sensors, read switches on Windows, all that sort of stuff, control panels. The good old, it's usually 6 or 8-core. I've seen 4-core. I've got some 6-core here. I've actually got quite a lot of this. The beauty of this stuff, let me just get blade. That yellow wire there would have come out of one of these. It's probably the exact same wire. You got to score it very gently. Don't even cut all the way through. Just let it go through at the very end, and it'll tear off of your score, if that makes sense. So you don't risk cutting the wires, and you just get a little bit out like that, and it just, yeah. And then once you've got it going, you don't even need to score the rest. You can just keep pulling. Look at it. It is beautiful quality wire. You don't buy wire like this on spools from AliExpress. It's cheap crap. I mean, this is top-notch stuff. Like, you know, good quality wire. You can feel it's nice and strong. It's thick. It's good. So I'll harvest a little bit of this up, and I'll use this for my connections. I've just trimmed all the wires up so that every piece of wire is no longer than that length, because I don't want inductance and ringing and stuff happening. And there's our nice colourful wire to hook up the bases and the bias string. I've cut enough here for both amps. So anyway, I'm going to get this wired up now, and we'll start testing it out. Alright, that's everything sorted. I probably should have done that first before trying to explain it, but I'm learning. So we've got our collector wires for the output stage, wires for the two bias strings, the wires for the 4 bases, the 2 feedback wires, the 2 ground wires. Where is my other power wire going? Whoops. Okay, I took one over there. And 2 power wires. Wait. Now I'm missing one for the other side. Hold on. Alright, that's better. Now I've got everything sorted. That's for that. And then I've already got same thing. That's all got its wires ready. All those wires are ready. So everything's ready to set up. I've got the 2 transformers on the way. I'm going to get another case. That's going to have to wait. Alright. The other thing I need to do, not right now, but when I actually, after we test this on the power supply again, I'm going to have to cut up. I've got some scraps, because I got rolls of this, but I don't take it off the roll unless I need long pieces. So we're going to cut some of this up. This is going to go between the transformer, the cap bank, and the center ground, and all that sort of stuff. Get made up out of that thick stuff. So I'll get all this connected and we'll give it a go. Something else I just wanted to touch on quickly whilst I'm hooking this up. When I was testing this out on the bench the other day, I had the feedback soldered to the output here. The best way to do it is to have the feedback coming right off the actual output, if that makes sense. So where these 2 wires intercept here, that come from the PNP emitters and the NPN emitter resistors, before it goes to the Zabel circuit, we're going to take our feedback from this point here, and likewise for the other channel. God, it's hard to get in here. I don't want that there. And I don't think it's stuck yet. No. Oh, goodness. Now I've got it. Very awkward spot to get to, this one. Alright, that is feedback on both sides. So that's everything hooked up on the output stage now. That is the total amount of wiring for both the channels and the power and the bias. So now I need to wire this board up. So I've got to give it ground and power rails, and then once those are on, well, that will get hooked up to this, and then we will power it up. Yes, okay, funny, I only needed one of those red wires. I don't know what I was thinking before. I actually ended up cutting an extra one thinking that I was short one. Oh goodness, things that I do. You know, it's funny because I cut these wires and then I put them away because I was like, I don't need these. I actually do, because each amp has 2 wires that goes from audio ground to main ground. So other than that, as you can see, I've got everything hooked up correctly. I'll double check it before I power it up. But yeah, I've just got to connect those up, and then what I'm going to do with the power wires is I'm going to solder them all together on strips of PCB so that I can get these clip leads onto them, and then we'll power it up. Alright, that's everything's hooked up. So I got all my grounds on one strip, negatives on another, positives on another. Yeah, I wanted that to happen. Bloody hell. Alright, so I'm just trying to get it so that I can have the entire thing in view for you guys. I can find a way of keeping this stable. There we go. Alright, that's stable like that. Get my power out. Yep. That'll do. That will do. You guys can see it. Yep, cool. Alright. Obviously I need to attach something to the output to load it and to get my scope on there. For now I'm not hooking up a capacitor, I'm just hooking this up to my power supply, powering it up, making sure the bias is all good and everything. If that's all fine, then we're hooking it straight up to the big supply. Then obviously rectifier capacitor bank. I'm just going to go once over again with all the wiring, you know, like make sure that the right bias diodes are on the right side and the right drives are going to the right bases and all that sort of stuff. I'm pretty sure it's right, but I'm just going to double check first and then we'll power it up. It looks like a bit of a mess, but it'll be neat when I put it in the case, because basically what I'm going to do is, so one bias string, the wires will be twisted together. The other bias string, the wires will be twisted together. Opposite base drives will be twisted together from the same channel, you know. So it'll look a lot neater. But yeah, anyway, enough talking. I'm going to get to checking and powering. It's a good thing I had a check over it. All my wiring's correct, but look at this. When I soldered the base wire in there, I knocked this off. One of the bases is disconnected from its drive, so I'm going to have to get in there and try and get that back on. I mean, it won't be too hard if I can get my soldering iron in there. Yeah, okay, I got it. Good thing I spotted that. I mean, actually, come to think of it, probably wouldn't have done anything because one side would have no drive, so it would just turn the NPN side on, the PNP side would be turned off. I've got no speakers hooked up to it, nothing bad would have happened, but, you know, it's still not good. And if for some reason the other side, you know, held some charge or something and did somehow turn on it, yeah, it could potentially go sour. I don't think there's enough gain just in an output stage and a driver to turn on like that. If it was a MOSFET, yeah, maybe, but I'm not taking my risk. So that's base drive hooked back up. I was looking in here and I was like, wow, the clearance on that connection's like almost touching the collector. I can't believe I did that. And then I looked at it and I was like, wait a minute, that's broken. I didn't do that. So now that that's corrected, yep. Okay, just quickly make sure nothing else is loose. I don't see how it wasn't from shit soldering. It's when I put the soldering iron in there to solder a wire, I touched it on the pad next to it and lifted something off of it. Yeah, no, everything's perfect. So I've checked the wiring. The wiring's perfect. I've checked everything, so it's actually ready to power up finally. I'm only doing it on the supply first, of course, because I don't want something terrible to happen. I'd rather have current limiting and all that. I don't like that. I guess I am only using this for testing. it'll have to do. Oh, you guys can't really see what's going on camera. The croc clips are not really making the best contact with these bits of board, but I think I've got it sorted out. Alright, I'm just going to let me see what my supplies are set up. I don't know what everything's set up at, so let's double check it. Now, I'm supplying 1 amp, so that should be enough. I'm just gonna hook the other supply up now and also set that for 1 amp. Oh yeah, that's right, you gotta short it. 1 moment. Alright, 1 amp there. $30 volts. I'm just gonna do the other side. Alright, 1 amp, 30 volts. Alright, just hook this back up, turn that off, put that in. Alright, I am ready to power up. Let me just double check my connections. Negative to positive, grounds, negative, positive. Yep, that's all good. Alright, I'm going to bring some meters over here, so I don't know how I'm going to fit everything, guys. We'll get there. We'll get there. Oh yeah, I need a ground point. I'll just use the end of this diode that goes to ground to clip onto. If I can clip onto it, there we go. I'll clip onto one channel's output just there. And what I'll do is I'll just get this cheapy meter because it's small. I'll put it on 20 volts. And I'll put it there. Actually, I need different leads for this. Almost there. We're almost there. That's 10 amps. Don't want that. Ground location. Alright. Output. Okay. We're ready for takeoff. So let's see. I'm just going to power it up for a sec, look at the current draw on my power supplies, let you guys know what happens. We'll see what happens with offset. If there's no offset and no excessive current draw, we will move the meters over to the emitter resistors on each channel, check the bias, and hey, if that's all good, you know what's next. That's me being optimistic. Everything could turn to shit right now. Let's see. Okay, that would not start up. I can't even explain what that was doing, but I've got a funny feeling that that was trying to draw too much current. My power supplies are sort of like oscillating. I don't even know what to say. That's annoying. Let me turn. Let me just think about what I'm doing here. I'm just going to remove 130 volt rail on each side and see if I can turn on. No. Something's wrong. I did say everything could turn to shit, yeah. I am kind of annoyed because this was working. I don't see what could possibly be wrong. I'm just going to turn the negative rail on. Yeah, there's nothing odd there. Okay, there is something odd there. Oh no, we just weren't connected. Okay, well, it's a negative rail. And it's the positive rail. Ah. No, that's because my current source just turned off as the capacitor's drained. Let me turn this negative supply down all the way, literally all the way, and let me see what happens as I start to bring it up. This is weird. Okay, what? You know what? I don't think it's my amp. You know what I think's going on here? I'm going to have to bypass the rail. Let me just set my voltages back. Sorry guys, 1 sec. Alright, that's set back up. Let me just get a couple of big caps and I'll just solder them across those boards to bypass the fuel supply that we've got effectively, and I'll turn this negative supply back off. Alright, I'll be back in a sec. Alright, what I've done is I've got a couple of 4700 mic caps soldered from each rail to ground there. Let's just give this another try, see what happens. No. What on earth? I am absolutely baffled. I powered up one channel the other day and this was perfect. I just don't understand. I haven't changed any of the circuitry apart from 2 diodes, and yes, they are round the right way. Negative rail. Positive rail. Alright, I'm going to try something. I'm going to try and put the negative rail on first. And try and bring the positive rail up slowly. What? What is making that sound? the heatsink and transistors, there's like some oscillating sound. You know, the only thing I can think of that's actually happening is that weird ass 2-pole compensation that I added is not working. Wait a second. Hold on a minute. That's the negative. What? Wait. How have I got positive voltage coming out with the negative supply turned on? Oh, my bad. That's the positive supply. What? Okay, so it's okay. All good. I was just absolutely tripping balls for a sec then. Oh, goodness. How annoying. How bloody annoying. What I think I might do, both channels are doing the exact same thing. The exact same thing. You know what I reckon? That output inclusive 2-pole compensation scheme's not working. If I had to take a guess. Because it's some sort of oscillation that's going into straight away. I don't need to put scope on, I can hear it. And everything's wired up correct. You can see both sides have got swing and can go to the rails and all that sort of thing. It's not a circuitry problem. Well, it is. If I just lift this ground wire on each channel, that will take one of those 2.2k resistors out of circuit, effectively just making it output inclusive compensation, which I had working on the breadboard. Maybe it doesn't like going to ground. I did read that some designs it has to go to negative rail, other designs it goes to ground. I mean, I could have messed that up. Wait, was that the right thing I just took out? Yes, it was. Alright, let's try that again. No. No. Okay, that's very interesting. Let's turn both the supplies up again. Oh, goodness. Yeah, I'm not going to let it keep doing that. Let me just make sure that hasn't. No. Oh, obviously. Oops. Negative side's good. Alright, God, this is freaking weird. I don't know what to make of it. I really don't know what to make of it. It's oscillating like crazy to the point that it can't start up. Put that back for now. I dare say if it was that, moving that would have made some difference, even just to the frequency it was oscillating at, and it didn't make any difference. So I've got a funny feeling it's not actually the compensation. And this is weird. I don't know what to say. This worked, and now it doesn't want to work off the same supply, bypassed with better wiring. Welcome to my life. Yeah, so I'm gonna have to take a moment and have a really good look at this and see what I can work out. I might, oh, God, I can't believe this. The annoying thing is, I don't even know where to start because other than the compensation network, there's nothing I've really changed apart from 2 Schottky diodes. I mean, I changed the size of these capacitors. I doubt that's got anything to do with it. It's possible. Yeah, I'm going to have a good think about this. I'm going to take a break, come back, have a think about it. Might unhook one channel and just try and power up one channel. See if it still does the same thing. If it doesn't do the same thing with only one channel powered up, I'm going to have to start looking into this. There's a possibility that, I don't know, something's wired wrong or there's some capacitive coupling going on between things. I don't know. It is possible with these traces here because these 2 diodes are for one channel, this is for the other channel, and that, you know, you've got that. I doubt it's that, you know. It's pretty weird. And it's not, like, this thing was not oscillating on breadboard. It wasn't oscillating when I powered it up the other day. So I don't think, you know, it's because the amp's unstable. I think I've inherently added something or done something that's turned it into an oscillator, and once I remove that, it'll be rock solid again. So I'm going to take a break, come back and see what I can dig up. Oh my God, you know what I've just realised? Oh my God. The Zobles. There's no ground wire. You know, if that's just a spike at power on and the Zobel's not quenching it and it's just turning and just running through the feedback loop because I forgot to connect the Zobels, I am going to I'm going to have a good laugh. It'll be pretty funny. Let's hope that that's what it is. Let's really hope that that's what it is. Otherwise, I'm still back to square one. Alright, let's get some 0-volt lines to the end of those caps. I just wanted to say, before I say what I'm about to say in this next part of the video, I ordered another one of these cases. I was trying to save up money for other things that are more important, but they've only got 5 left. On AliExpress, I don't imagine that's going to last long, so I just grabbed it. So another one of those will arrive in 2 weeks, plus the 2 transformers. So, I mean, there's that at least. I will continue on with the rest of the video now. I have finally made progress. It's absolutely hilarious what I've got to explain to you. Alright, I know no one's going to believe this. You might be able to tell from looking at the board, but basically yesterday, after I discovered that the Zobels weren't connected, I powered it up again and there were still problems. So, I don't even know where to start. I mean, just look at my bench. Might give you an idea. So only on this board, not the other board, the 2 emitter resistors for the VAS transistor was 680 ohms, not 68. So I've corrected that. I didn't realize that until I started messing around with the circuit, loading different parts of the circuit, removing parts whilst it was powered up, and then the 680 ohm resistor started smoking, and it was sourcing its current through a 47 ohm resistor, and I was like, well, how on earth is that 47 ohm resistor not smoking? Or at least, you know, warm if it's sourcing the current that's smoking a 68. So I looked at it and I realized it was a 680 ohm resistor. Anyway, where do I go from there? Turns out we have no bias. The other day, some of you might remember on the meter, there was roughly the same bias voltage in AC as what there was in DC. Well, yeah, without having this all wired up nicely like I do now, bypassed with capacitors it is now, and all that, there was all this noise and stuff. I didn't have the disables hooked up. Feedback was taken off the wrong point. And that was what I was seeing as current through the emitter resistors. And just by adjusting the bias, turning it up, because it's decreasing resistance between the base of the NPN and PNP side, it reduces gain. So that's all that was happening. What I've actually discovered, I'll just power this up just to show you guys quickly. So, I'm not sure if I've mentioned this in the video yet, because I deleted a whole bunch of scenery because it was just me just going through stuff for hours. You don't want to watch that. I've removed the 10 kilo ohm resistors that I had in between the bases of the pre-drivers. The protection diodes, the bias string, and the 4.7 mic cap's still there, but the 10K is not there no more. Anyway, that's neither here nor there. Yesterday I was having trouble getting this to even power up properly. When I left the room, I shit you not, I looked at the power supply and my negative lead was in the earth slot. Yeah, we only had a positive rail and a negative reference to ground through capacitors, because I've got 1 mic caps between the posts to ground for decoupling, and that's what was forming the oscillation. Anyway, after I corrected that, good news is the amp's wonderful. I'll just show you guys offset first. I'll just do one channel at a time. So offset is literally nothing, right? And the other channel, that was lower before. Not too sure about that. Anyway, I'll sort out trimming all that sort of stuff afterwards. So the problem is that if I look across just one of the emitter resistors, there's no bias. And here's where it gets funny. Really funny. In an amplifier, if you open up the bias spreader, whether it's a VB multiplier or a string of diodes, what would happen? You'd smoke your output. Both sides would turn on hard. Current would try and flow through the transistors, through their emitters, through the emitter resistors, into the other transistors, and it would all go up in a pile of smoke. I've done it before, trust me. Anyway, watch this. Now this happened by accident, but that's what made me realise. Yeah, that's powered up of 120 volts. So you may ask, why is nothing happening? No current, nothing. Still zero offset. Alright, maybe it's a bit lopsided, but I mean, I've just disconnected something that's a crucial part. What? Okay. We'll come back to all that later. Anyway, the offset was like 0 yesterday. I've been messing around with things. That's probably all it is. Anyway, let's see what the bias voltage is. Yeah, that's a bit of a problem. And that's the highest I've seen it. If I put the bias spreader back in, which is now a shrinker, 2.7, 2.6 volts. The fluctuations just because all that diode string's just on the edge of the conduction and the current source is not supplying enough current for it all. So what's happening is the VAS transistor needs, sorry, the current source up here for that stage needs to be increased. Now, the transistor, okay, something else I need to point out other than just those 68 ohm resistors I had to change from 680 ohms to 68 ohms, excuse me. I found that the current source for the input stage was running too hot, so I changed its resistor to 470 ohms. It's now running at 3-ish milliamps. It could be a tad over, like 3.1, 3.2, but it's just warm now. I might even slightly increase the value of that resistor a little bit more until it's like, you know, a bit more than warm but not hot, if that makes sense. But anyway, there's enough there at the moment, I think. So what I'm going to do, was there something else I did too? Oh yeah, I ended up taking the Schottky diodes out, putting the normal ones in, because at first I just thought my bias spreader was too small. And after doing that, I found out that no, there was no bias voltage there. And whether I have the spreader connected or not, if I just actually hook on to the bases of the pre-drivers where the bias voltage is, if I take, say, a 1K resistor and I'll clip it onto the VAS current source resistor and touch it over it, you see that goes up 2.8, 2.6. So I need to increase the VAS current source. That's all I'm going to say in this video. What I'm going to do in the next video, I'll discuss everything. The 68 ohm resistors are going to come back out. I'm going to basically start with, I don't like to see more than 200 ohms in the middle of a bias spreader when it's made up by diode strings. So that's what I'm going to do. I'm going to put 200 ohms, like just where the pots are, just like basically ignore the pot and the resistor. I'll just lift that all over and I'll just put 200 ohms across each one. Or I might even do 120 like what I originally had, because that worked even good at 1 milliamp, and the diodes are going to track more with more current. So I guess the resistance could even be higher there. But basically, yeah, I'll put a couple hundred ohms across that. Actually, I've got the Schottky diodes in there, and I've measured the volt drop difference on them too, and they've got like 300 millivolts dropping on them, and the string diodes have got like close to 500 millivolts. So I don't really have adequate bias current to take these measurements, but just out of curiosity, what do I have across my resistors? 200 millivolts. That's about 100 ohms there. So 1, 2. Tell you what, I'll put 470 ohms across each of the middle of the two diode strings and leave these Schottkys in there, and then hook this up to here or across the emitter resistor. It doesn't really matter. I know what voltage I'm looking for, and just start increasing the VAS current source until we get enough bias. The next problem is probably going to be, is there enough drive? I know the front end's got plenty of drive. I know this stage here has got plenty of drive, but I don't know if the VAS current source, these transistors and this little circuit here, which basically flows like this, if that's going to have enough drive with the output stage loading, the base sucker resistors and caps, all that sort of stuff. So we'll work out the bias first, but yeah, I just deleted a whole load of footage, and I just wanted to come on and shorten that up for you guys. I also tried a whole load of other things, like after I got my power rail back on, I tried removing the compensation components just in case there was some sort of strange oscillation I wasn't picking up on, or the absence of one that was making it act differently the other day. And it turns out that the reason I had bias the other day, like I said, it wasn't bias, it was just noise and stuff. So yeah, anyway, I'm going to end this video here and then get on to a new video, which will be, like I just said, putting 470 ohms of resistance in the middle of each of the diode strings and increasing the VAS current until we get bias, setting the bias, and then putting a signal through it and seeing what gain we have. Now, as it is now, with 4 milliamps and 4 milliamps on this end before I changed it to 3, I had a gain of 7. I already put a signal through it. So I set it for a gain of 26. Even if it ends up like 25, 24, I lose a little bit of gain, that's fine. Or maybe it's not, that might cause distortion. I'll have to look into that. But anyway, I'm aiming for a gain of 26. That way, you know, even off 1.8-ish volt signal, you'd still be able to drive 250, 300 watts into an 8 ohm load even, off a line signal. Anyway, so I'm going to end this video here, and like I said, in the next video we'll sort out the bias and all that sort of stuff, the VAS current source bias. Yeah, take it from there. Alright, well, thanks for watching. I'll see you all soon.